Okay, can you hear me, guys? Cool. I'm not gonna ask who knows the answer for the chess puzzle. Before we start, it's the only legal move here is d4. Of course, there's no other way. You must win. It doesn't matter which piece the black promotes to. You win. So we're starting in a minute. One note before I start. I have over 70 slides, so this talk will be fast-paced. If you have questions, please keep those questions to the Q&A session, if possible. But you can always, scream if you need to. And yeah, that's it. Actually, this talk won't be that painless as it should be. I lied. We're locking the doors. We're locking the doors. You have to stay because there is no way to be painless with SELinux. No, I'm just kidding. Don't worry. Won't hurt. How many of you have written a policy, a SELinux policy already? Okay, that's quite a number. 10, perhaps. That's good. Hi. And can we start? Oh, of course.
To start recording.
Sure. Okay, can I start? Good. So, a few years ago, our project or product, Satellite 6, which I'm working on, I had a task to write a SELinux policy. So I volunteered. I've been sent to the SELinux training 1 week with a certification, and then I started coding. I took a trial and error approach, and it worked, kinda. And over those 3 or 4 years, I've learned a lot of useful tips and tricks. Lots of these by myself and others, by putting questions on the SELinux guys. So I've decided to do a talk full of these tips and tricks. And before we get to the tips and tricks, I'll do a very rough overview of what SELinux is. It will be very simplified. Bear in mind that this will be only for us to get us on the same page. If you want to know more, search for Dan Walsh, SELinux, and you'll get what you need. We're not covering deep things. We're not covering administration at all. I will focus on just bare minimal, just to have enough information to write a policy or something. This is also not a step-by-step tutorial on creating policies. It's, I would say, complementary. When you search for how to write a policy documentation, you find usually a documentation that gives you hello world, and this is rule, this is how it looks like, and then you are on your own. And I would like to complement that and provide you with some tips how to improve your workflow. This is a lot of information about workflow, and yeah, let's go ahead. So SELinux is a module that enforces a policy. This is a nice definition. In other words, this is what I like to say. It makes sure that programs do not misbehave. By misbehavior, I mean working against a set of rules. This set of rules can be pretty fine-grained. SELinux, can do pretty well in this area. And here, this picture is coming from the wonderful coloring book. If you don't have your own copy, go and grab it. We don't have copies here physically. Those animals represent Linux processes, and for SELinux purposes, we need to tag them somehow. For this, we use SELinux types. Cat and dog are types, and you can think of a type as a string, as a constant or label or something like that you assign to a process or resource. If you assign a tag, or if you have a type that is reserved for tagging processes, we call it a domain type or domain. Then we have some resources. The food here represents a resource that can be a class of file, directory, symlink, UDP, TCP port, a local socket. And those types need to have, those resources need to have types as well. So SELinux leverages something called extended attributes for that in case of files. And for TCP and UDP port, you have a mapping list or table of port numbers and assignments to types. And then we have, writing a policy is really writing a text file of rules that constrain an application. And they are, in a form of allow. That's a keyword. Then you have a source type, which is usually a domain. Then we have the food represents the target type or destination, which is usually resource. And we have an action, or I would say permission. And so in this case, SELinux observed that behavior. This is correct, obviously. But in this case, when our dog represents a Linux process and the resource is maybe a configuration file somewhere, and the action and permission is open it for reading, that system call, if the rule is not there, that system call, thanks to the SELinux, which will prevent that behavior, will end up with an error instead of file handle. So the system call will return error. This is important. SELinux can prevent misbehavior, can prevent from errors or bugs, security bugs mostly. There's much more than that. We are at the end of my explanation what SELinux is. We'll slightly touch transitions then, but this is all I have for you. And so there's things like multi-tenancy, which is good for OpenShift. There's things like MLS, secret, top secret, confidential stuff, but we are not covering that. You can do just fine writing your own policies without knowledge of what MCS or MLS is. And I'm doing this every day, so I can tell you. So how can SELinux help? So first of all, I like this one. It prevents from various attacks. We've seen a nice talk about shell shock. Given a Git hosting service, which is enabled using SSH, Git over SSH, you have some kind of shell wrapper that constrain the user to spawn a Git command and do stuff. If that's a shell shock vulnerable, and if this is running confined, we say our application is running confined when SELinux is enforcing the policy. Then if your rules tells something like this application can only spawn Git, can only read Git configuration, and can only read data from /service/Git repos, if an application makes use of the shell shock and tries to spawn a shell, tries to spawn anything, SELinux will prevent from doing that. That's how it works. Although SELinux is not a golden hammer, of course, there are some other bugs and situations where it can't much help. For example, SQL injection. Web application talks to the database, and so we're using a TCP socket or something. For SELinux, this is just a data flow, and it doesn't understand the data flow. So if instead of select it's doing delete, SELinux can't help you in this case. On the other hand, which I particularly like, is if you have taken a server offline and you're investigating stuff, and your manager asks you, hey, okay, we have a flaw in our application, that data was stolen, but was the attacker able to connect to a remote service that holds our more sensitive data? You can tell from your policy, yes or no. Because if there was a rule, he could. If there's no rule, no chance. So it can help you even in those worst situations we don't want to be in. More than that, it can help you find software bugs. Not many people know that things like unchecked file open values, when program doesn't correctly check for the handles, in the case of file is not can't be read or write, open for reading, writing. It happens, and if you're doing your policy writing, your workflow right, you find those bugs easily. Leaked descriptors, another example, is great. Now, if you run Skype for some reason, or a third-party database system, and you don't have a source code in your hands, you can, thanks to SELinux, make sure this process won't misbehave. Again, you can give it some rules, and it's surprising that some application, if they can't if they can't read something, they still keep running. So maybe you can create a policy that won't enable Skype to read something, but it will still run. So it's a workaround. So let's have a look like how SELinux policy look like in Fedora RHEL. So basically, it's as I've said, kernel module, of course, and then a set of tools and the policy itself. The policy is shipped in the SELinux-policy package name, and the first one ships with, I think it's a meta package, or it contains the configuration files. The one we are interested in is targeted. Targeted, the name stands for the variant or deployment type. And the target is the default one, which you end up when you install Fedora RHEL, and we'll be focusing on the targeted in this talk. This package contains some things like file context definitions and the policies themselves. They have an extension of PP. PP stands for compiled policy module that you load into your SELinux, and we'll be compiling them in a minute. Another interesting package is -devil, which contains makefiles we'll be using in a minute, interfaces and support types, which are very interesting, nice knowledge base, I'll tell you later, and some administration-oriented things like manual pages and HTML documentation. Now, a policy is just a bunch of 3 files. Basically, it works with the one file, but for sake of completeness, let's take a look on the 3 files. Type enforcement file contains your rules. It's a text-based. All are basic text-based. IF file has the same syntax. We'll get in a minute, and it contains rules which are to be consumed by other policies. So it's a public interface, public API, I would say. And file context contains your default definition for file contexts. So to compile a module, you first need to have a policy module macro in the TE file, otherwise it won't compile. And then you call make. Make file is coming from the devel subpackage. Here's the first tip. If you do a symlink into your working directory, just type make. And the resulting file is pp, which you can load or list as a module. Nice thing is that if you load a module, SELinux will remember that. Not like just firewall command, which you need to provide with -- permanent to do this. So it will remember. The make file contains a lot of interesting stuff. The most used, I would say, for me, it was load, reload. So you can change your file, save, reload, and it will automatically compile and reload your policy. Refresh is also nice when you want to start over, when you need to reload everything from scratch. And there's several other variables which have same defaults for us. We don't need to change them. So here is an example coming from the devel subpackage. It's an example shipped with the SELinux policy devel subpackage. And let's take a look on this. We'll cover the syntax in a minute. So after the policy module statement, you usually need to declare your domain, which will be used for your application. In our case, this is type myapt, and we give it a domain type using the domain type macro. Excuse me. Now, I missed one particular thing, which is transition. You need to have some way to get into this domain, because if you start a process, it will, I think it will inherit the parent's domain. You need to have some kind of entry point. There are two basic types of software, I would say, I've been dealing with, coming from my experiences, and these are standalone binaries you spawn and daemons. And for standalone binary, you usually execute an executable file, and that it loads up. And so for this type, this is the example here. We need to the way you change the domain, the way you get into your domain is that you define a helper, I would say exec_t type, and you assign this type to executable file to your application. And you need to create a transition that tells, basically, that's the domain entry file line that tells if an application is executed, if an executable file labeled with this exec_t type is executed, then do a transition into my application, my apt domain. Now, it looks scary, but trust me, I've been doing pretty well without knowing all the details. I've never visited the domain entry file interface. I don't know how it works, but you can copy this from other policy, and it changed using a replace, and it will work. The other case is when you are writing policy for a daemon. Then you need a little bit different entry point when you need to deal with systemd and init script and do the transition from there. But it doesn't matter. You can copy it and use it. Won't stop you from writing your first policy. Then we have some file types for log files and TMP files. And then we have our first rule, main to read or append files which are tagged with myapp_log_t. That's what the rule says, basically. It's no magic. We'll cover in a minute other forms. This is an example of the IF file. This is the same syntax. It's M4 language, or expanding or macro language. I'll cover that in a minute. So let's keep the first one. It's a little bit more complicated. The second, myapp read log file, this is how you define an interface that other policy authors can consume. So in this case, if there is an other application that would need to read your logs, without the rule, there is no way to read it. You need to add a rule to that application, and you can create this API so other policy authors can have this rule and don't repeat themselves. We'll cover the syntax in a minute or so. An FC file stands for file context, and it's basically 3 columns text file. The first one it's not a shell glob. It's a regular expression. So I always do a star instead of dot star there. So keep in mind this is a regular expression. The second column tells if you omit that, it will match for everything. -- means file, -t means directory. And the third column, again, we're not covering things like users, roles, and MLS, MCS stuff. That's the S0. All you need to know is that you can verbosely copy that from a different policy or from a example file and change the desired type you want to set. So in this case, user has been myapp will be when you do a restore con, it will be tagged as myapp_exec_t. So this is what we want. When we execute that file, it will do the transition, and our application will be running confined under the myapp domain. Okay, so here's the first tip. The best knowledge base out there is usually our Red Hat SLinux team, but before you contact them, you can go ahead and search in the devel include in the devel subpackage. You will find there a lot of interface files. Some of them are core, I would say, which reside in kernel and system, I think. And the others are from the contrib subdirectory, and those are policies for services and programs which ships with Fedora or RHEL. And the good thing about this is if you learn how to navigate those interfaces, and I'll show you how in a minute, you have a nice knowledge base of the definition of the interfaces themselves, of course, so you can investigate what they do, but also a nice set of usage. With interfaces, you can find SPT files, which stands for support types. It has the same syntax, but they have different naming conventions, and we only have 8 SPT files in the modern Fedora distribution, while the IF files is almost 500. So when I first ran into M4 many years ago, my first ever task when I signed in the Linux system for the first time in my life, I tried to reconfigure SendMail. And then that day, I had to play with the auto tools, and I have no idea what M4 is. I was like, what is this little quote? It looks strange. But SLinux learned, I learned from SLinux that M4 is a efficient, small, nice language, and it works, easily, and you can learn it in a day. You don't need. For SLinux, you only need to know like few macros or definitions or keywords or whatever this is. I don't really know. And actually, I learned the other day that Upstream is working on a modern, more dynamic list-based language. When I found that, I think I like M4 more than before. So this is how it works with Makefile for the default Makefile. It will expand. M4 is just like RPM, expanding language. It's macro language. So it expands to what we call a SELinux language, the final version or final, file, and that is stored in the TMP, your project name TMP file. If you have a syntax error, and believe me, you'll have a lot of syntax error when you start with that. At least that was my case. SLinux, I'm not sure if this is SLinux or M4, will tell you exactly your TE file and line number, which is great, so you can fix it easily. On the other hand, there are some cases, I think this was with older versions or something, when you don't see a line number of your TE file, but what you get is line number of the TMP expanded file. I was like, what, 10,000? Jesus, but don't be shy to open it. It just contains a lot of empty lines, a lot of comments, but you'll eventually find your bug there, and you can easily fix the TE file there. Here's another tip. We will see that some lines end with semicolons, some are not. The golden rule here is the SLinux syntax itself, and those are the lines that starts with type or allow, and then I think this is pretty much it for our talk. Must end up with semicolons, but all the other one must not. If you do it the other way around, it won't work. So you just need to remember that everything starts with allow or type. Usually you need to have a semicolon there. Okay, interface naming is an interesting tip. If you start with SLinux, you will sooner or later find out that you're not writing allow rules. You're actually writing against interfaces. You're adding a lot of those interfaces, those are like functions, right? And the naming convention here is that I think 90% of the core policy follows that rule. It starts with in this case, files, which represents a file which this interface was defined in. In this case, files IF, so you can easily find it. Then it's the permission, read, append, or something. Underscore user files is the last bit, which is a little bit free form, I would say, subject. And you get used to it very soon. I already know that this represents /user, so user files represents /user. And so let's take a look on the M4 syntax. You already noticed the quotes. It starts with a back quote, ends with the normal single quote. And every time you need to use a type, you either need to declare it using type something, or you need to require it. For this, SLinux utilizes a require keyword, but don't ask me why. The good practice is used to gen require. This is I think, for the optional box or something. It eventually expands to require, but every time you want to require a type, you use this macro gen require, and you'll be safe. Otherwise, you'll get some strange error, and you'll be finding this in the TMP file, the long one. And then we see that the syntax is quite. You can get familiar with it in a minute. This interface takes one parameter, that's the $1. And it basically allows to list the first rule. Allow means that allow the first parameter, which will be usually a domain, to list files or directories which are typed with the user T. And then, by the way, list their permission is not an interface; it's a support type, and the same for read patterns there. And then we have two support types that gives those allow rules. Let's take a look how it works. This is a support type. You can see that support types are defined with a define keyword or whatever this is, and not with the interface or macro. And this one expands to list of permissions. They eventually map to system calls. I'm not sure if all the permissions map to system calls, perhaps not, but doesn't matter in this case. And here we see 2 examples of 3 parameters, support types. As you can see, they expand eventually to a macro. Again, they make use of other support types. So usually the expanding level is quite high in SE Linux, but it's obvious from the name, so you don't need to know every single allow rule in your policy. You just need to know that the read files pattern gives you what you need. Last week, this nice book was published, and I highly encourage you to download it. To buy a copy. And if you don't, you can download it online, of course. And if you even don't do that, you can go and download for free examples from this book. And the examples zip, I think, contains function.sh, which gives you 4 nice little functions. You can include it in your shell environment. These are shell functions. SE shows something and find something. And the SE show interface or definition, that's definition means for support type, is great because it will show you the whole body of the interface or support type, which is great. But what I find even more useful, here's another tip. Use SE find interface to find for occurrences of the interface you're looking for. And with this, you can easily find interface itself, the definition, the declaration, but as well as the things, the usage from contrib subdirectory. So maybe you're looking for Apache Tomcat or Tomcat domain template, which is a template interface you'll be using for creating your own policies for your applications. You can see if there's a use case in the core policy, and then you can copy it and change it. So you don't really need to start from scratch. If you're using tags with your editor, keep in mind that CTags doesn't support SE Linux natively, but there's this hack that was published years ago on the SE Linux mailing list that gives you, a working text file, and it works great. I'm using that every day. And if you're a happy Vim user, you can download my package, which contains this script, the macro for that, binding, and slightly improved M4 SE Linux syntax highlighting, I guess. What's great, I think this works both for Vim and Emacs. If you have a text file, it will get you auto-completion automatically, just for free. So maybe you want to add a rule to connect to SSH port, and you are not sure where this would be. So you start with core network, because you already know that core network interface contains all the, or most of the interfaces that has something to do with network, and you type Control-N in Vim, and you have it. Okay. If SE Linux experience misbehavior, the end result is if it's running in enforcing, it will block the action and send a denial to the lock. If it's running in a permissive mode, that will, it won't block the program from doing that action, but it still will give you an audit log. Audit log or denial log is something you can find it on the Red Hat system in audit log. And it has this tag AVC, which stands for some vector cache or something. The most important thing is the anatomy of this. So you find a name bind that is the permission, which maps to a bind syscall eventually. And then we see PID, we see a process name without parameters. We see source context and target context. So again, we're skipping user roles and S0. We're not interested in this. We see that the passenger T is the domain. The application that was running in passenger T tried to bind UDP socket that was from the unreserved port range. And SE Linux did the job for us already and extracted the source port, which is in this case 1251. So we now know that this program is trying to bind UDP. So it turned out this is for the DNS, DNS resolve. Here's another tip: if you want to, know if there are any denials, and maybe you want to file a Bugzilla, use audit search -mavc, which gives you the exact line that was shown with the grep one, but it will show you also the syscall, which was associated with this denial. In this case, it's not that useful because the interesting things are under the struct pointer there, and SLLinux already extracted that for us. But sometimes you get a lot of useful information in there. Here's a wonderful tool called Audit to Allow, which can turn audit denials into allow rules. It's awesome. The first case, generates allow rules for all your denials from the point the policy was reloaded. The -R gives you tries to make use of interfaces when appropriate. And you can use here's a tip. You can use a standard input to if you copy and paste it from Bugzilla or something, it works as well. And the last one is if you do a $M, it will generate and compile a policy for you, so you can have a quick fix. Now, when I first learned about Audit to Allow, I thought like, okay, my work is done. I'm done. So what I'm gonna do is I'm going to put my server into permissive mode. That's what I'm gonna do. Second, I will run our test suite, and that will run an hour and do everything possible with my application. And I will end up with many rules, and then I can git commit that, and I'm grab a coffee or something. Well, it turned out that this is not the right way to do this. Of course, I failed. Okay, first of all, as I showed you, you need to have some file context. You need to do the initial transition. If you want have this set up already, you end up with the garbage. Useless, it's not working at all. Even if you create those, if you create the block, the declaration block, and create a file context and set it and restart the application, you're actually not doing great because the bugs I've told you, the file descriptors and all the stuff, you can't actually find them because in permissive mode, the action won't be denied. So file will be opened, for example, so the application will never run the issue. It will never segfault or something. And you're not following the least privilege principle. Nobody does today firewalling like opening firewall, then running all the applications and marking all the ports that were used, and then turning it off and only opening or closing the other ones and keeping those which were used open, which is not a correct way to do this. So what I like to say is the policy itself is not the only artifact that you're getting from this workflow. It's not more important, but it's as important as the policy itself, and that's the process, which you can imagine like an audit of your source code. When you hire someone to audit your source code, he will eventually find some bugs. But with SELinux, writing a policy properly, you're doing audit of behavior of the program, which is great because that's very different from audit of the source code. You're auditing, the behavior, and you're about to find things like misconfiguration, bugs, or design issues. Examples: maybe the program is reading a SSL key file for some reason, but it shouldn't. It could be some security flaw to have this key in the memory. Why? It doesn't use it, so it's a bug. Maybe there's a misconfiguration. The program is supposed to connect to Postgres instance using local sockets by default, but for some reason it's connecting via TCP, which is a performance issue, could be. And you can find easily those bugs and misconfigurations and fix them. You're not going to add a rule in your policy. You're going to fix the software itself, file a bug, and discuss this with developers. So keep in mind that writing a policy is like audit. You're making your software better. It's not only about the policy and getting those advantages. So, and this is not out of my head. This is, how you should write policy. It's well known that it's good to take small steps. Run your SLLinux in enforcing. Well, you should always run in enforcing, right? But in the development, don't do permissive. Do the first initial transitions and file labels, and then modify, compile the policy, load it, and start your program. It will crash eventually in a minute or in the second. Well, not trying to load a atc/myapp/configuration file because there's no rule. Remember that if there's no rule, there's no way it won't work. So add your line, maybe go into the source code, check if everything's correct, and repeat. Do this over and over again until you have a working policy, and you'll take advantage of all these good things. Here's another tip. I've been pretty bad in this last year. Every single commit in Git, when you have a stable policy and you're improving it, because it's not about bugs in your policy, it's also about because the software itself changes, and then it now binds another port or something. Always include denial with the commit message and the syscall as well. It's not here in this example, because I can tell you in 3 years you won't be able to tell each particular line why the rule is there. So, and the syscall and AVC line will tell you a lot of information. Now this is a nice one, not a technical one. When we were discussing how to approach this within our Red Hat, I'm from the Satellite 6. There was an idea that someone from SLinux team could write the policy for us, because they know SLinux well, right? But it proved that even if someone with a great SLinux knowledge would write a policy for your software, if that software is complex enough, and we're talking about Satellite 6 or OpenStack, that composition of like tens of open source components, then learning steep of SLinux is much steeper than some projects. So we would eventually end up with a loop of many questions. Does this program need to read this file? What this cache directory is for? Do we allow write or not allow? So we took a different extreme. We've been trained and tried on our own, and it turned out that it worked. Now we are two with some SLinux knowledge in the team, and we review our patches each other. I highly encourage you to do the reviews, because even it looks like easy, it's just a bunch of rules. You can do bugs, you can do, we're dealing with security, so you always want to be sure. And only in the case when you're not sure, because there are some hidden secrets, hidden dragons here and there, you can always ask on the list, and guys are pretty responsive and helpful. So, and you can also, what we do is we ask them for a review. If we are not sure about the patch, they will review the patch for us and find the flaws and possible bugs. Here's a tip. If you need to deal with the multiple versions like RHEL 7.6.5, and guys usually change the interface names. And if the one way of work around this is to do a Git branch. But if your policy is 100 lines long and you need just 3 or 4 lines, you can take leverage the distro flag variable that comes with the makefile, with the default one. And if you set it, it won't be set automatically. This was the snag that I've been fighting for an hour. But if you set it manually, then you can use ifdef or ifndef macros to actually branch your code. So you don't need really to git branch or something. Okay? Now, deployment in question. There are multiple ways of deploying SLinux policies. If the software you're writing policy for is already in RHEL or Fedora, you can send patch to SLinux core policy, which now is hosted on GitHub, I think, from the last year. And eventually it will be included. It's good enough. The other extreme is if your software is installed from third-party repo, like Foreman, which I'm working on, you need to ship your policy. Shipping a policy is really all about copying a PP file and then loading it in. The proper way, of course, your Red Hat is using RPM packages. So we have an RPM package. We adopted an approach from Spacewalk project here and slightly improved that. We have an enable script which loads the policy and sets some booleans and ports. There's a hack too, because every single SE manage command is slow, so we're using a temp file to do some things in one transaction. Then we have a relabel script, which relabels using restoreCon. It will relabel all the files we are interested in to the default file context you've already defined in your policy. And we don't want to use a slash because that would be slow. So we only relabel those directories we are interested in. And then you have spec, which is easy. First of all, we need to determine RHEL, if it's RHEL or Fedora. We do support RHEL or Fedora for SE/Linux currently. And then we call just make, which was slightly improved in our case, which does installation for us and several other things. Here there is post or scriptlets which do enable or disable or relabel depending on if you're installing, upgrading, uninstalling stuff. And shipping a policy is really copying a PP file. In this case, it's bzip compressed by, you don't need to compress it. And then you can ship, it's a good idea to ship the source code as well with a binary package. Okay, be prepared, brace yourself, because if you're doing SE/Linux, you won't be perhaps a rock star within your team, because it's usually not a product feature, the top 3 product feature, because in Red Hat there's this rule we always ship with SE/Linux. On the other hand, which I particularly like, is if you need to clean your head, the SE/Linux is great, exit. I would say there will be always some bugs on the SE/Linux component in Bugzilla. Not because your policy is maybe bad, but stems from the fact that the product or projects are changing. So you need to align the policy. So it's a good way to have a break. Okay, we are just on time. One more thing. If you want to remember just one thing from this slide deck, please remember this one. If you're going to file a SE/Linux bug, please always attach list of denials, and please do use audit search-mavc, which gives us a lot of more useful information. If you can, please do restoreCon rvn/, which gives us a list of files which are mislabeled, which is always a good help. And if you want to be a rock star, then do a PS capital Z, which ships a list of processes with their domains, which is great stuff to have. All right? Remember, denials, files, processes. Okay. Just in the time, questions.
I was writing SE/Linux policies for daemon tools like a year ago or so before running was in place. But what I kind of got across was I was writing it based on the audit log, and after a while I kind of wrote a rule, allow rule for every single kind of condition which didn't allow for daemon tools to run. And I ended up the daemon tools still was not running, but I had nothing in audit log at all. I had no ABCs at all. What should I do in this case if I ever have a bit problem?
Yes. So the question was writing a policy, and there were no denials, but the software was not yet working.
Like with permissive mode, it was.
Yeah. Okay. Sure. It happened to me as well, and I asked SE/Linux guys, and they provided me an answer. That was because there are some rules that are turned off. They call them don't audit, I think. And what you need to do is you can switch SE/Linux to ignore don't audit rules. Instead of allow, you can do don't audit, or something like that. And the rule will be blocked, but it won't be logged. And maybe you were hitting some kind of this issue. So what you need to do is semanage I think capital B, which will turn off those don't audit rules, and then you'll see what happened. Might help. Other questions? Okay.
I wonder if there is any effort to do the opposite, to start to clean up SE/Linux, because, for instance, we just migrate to system D.
Mm-hmm.
So hopefully most of the daemons and servers are not using the old configuration style and everything. But this is still with, they are still in the SE/Linux policy. Are there any plans to clean this
So are there any plans to clean in regard to the system D?
No, to the SL limits in general. I think we shape a general database for everything, but at some point this will get stale.
Yeah. I have to say I don't know. I'm not from SLinux. I was just writing a policy for our project. I guess guys are working on improvements every day. So yeah, eventually there will be some improvements. I'm sorry, can't tell you. Anything else? Please come over to me if you have more questions. Thank you.